Here's a 2010 AB, 2010 Form B, number 5. Looks like some differential equation action here. On the axes provided, sketch a slope field for the given differential equation on the 12 points. That's a lot for a slope field for them to ask us to do 12, but all right. And for x values here, sketch the solution curve that passes through the point 0, -1. All right, so let's sketch the slope field first. Let's see. Let's start at the top. So the y values here are 2 for all of them, and then here I have -1 plus 1, that's a 0, so I get 0 slope. And then when I move over to here, I have 0 plus 1 over 2, that's a half. So nobody's going to get out their protractor here, but you do your best to get those as close as you can. And then 1 plus 1 over 2 is 1. A slope of 1, nice 45-degree there. And then here, well, let's recognize here that whenever the x value is -1, that's going to make the top of this 0. It doesn't matter what the y is. So 0. And don't draw slope field lines on places where they don't give you points to do so. And then here, when x is 0 and y is 1, I get a slope of 1. And then x is 1, so 2 over 1. That's like steeper, something like that. And then when x is 0, I get 1 over -1. And then here I get 2 over -1. That's a slope of -2. And then here, 0 plus 1 is 1 over -2, so -1/2. And here I get -1, right? Because that's, yeah, 2 over -2. Okay, so that's what my slope field looks like. And they want us now to sketch the curve that goes through here. Well, if you go along this curve, you have it's a straight line. You get to a place where you have the same slope. So it's not bending like toward a different slope. It's headed right toward a point that has the same slope. So it looks like we just have a line that goes through there. All right, check. Part B. While the slope field in Part A is drawn at only 12 points, it is defined at every point in the xy plane for which y does not equal 0. It doesn't have any, you don't have slopes where y equals 0 because y is in the denominator there. But any other xy you could do, right? They're just reminding us that this is just like a selection of points. You know, you could pick like x equals like 0.1 and y equals like e over 2 or whatever, right? There's slopes everywhere. So they want us to describe all points in the xy plane, y not equal to 0, for which dy dx is equal to -1. So that seems like a weird thing for them to ask, but I mean, let's just do it and see what happens. So, for which dy dx equals -1. First of all, I don't know if you recognize that, but that's the slope of this little bit that we just sketched here. So what I would do is I would take the differential equation. If they're saying dy dx equals -1, well, let's just plug in that -1 here and see what happens. So -1 would be equal to x plus 1 over y. And then just doing a little bit of algebra here, so I'm just multiplying that up here. And then flip all the signs so it looks like the equation for a line in slope-intercept form. And sure enough, -x plus 1, that'd be a slope of -1 and a y-intercept there. So how would you describe all these points? All points where dy dx equals -1 are on the line y equals -x minus 1. That's what I would say. All right, part C. Find the particular solution. So here we're going to actually solve this differential equation. Have to do that by separation of variables. The dy has to be over here and the dx has to be over here, and we have to move any y's over here to the other side, so that's going to move up here because algebra, so that would be y there, and then the x plus 1 going to stay right there. And then do a little bit of calculus. Antiderivative of y is y squared over 2. Antiderivative of x is x squared over 2 plus x, and then I'll put my constant of integration over here on this side. Now we know, oh, they're giving us a different point here, and it goes through the point 0, -2, right, with this initial condition. So we use this to find the c. So let's see, plugging in 0 for x and -2 for y. So that gives me -2 squared is 4 over 2. These go away because I'm plugging in 0 for x. So c is 2. So that means I got y squared over 2 equals x squared over 2 plus x plus 2. And we should solve this for y. So I'm going to multiply through by 2. Y squared equals x squared plus 2x plus 4. And then y is equal to plus or minus, I'm just going to hold off for a second. There'd be a plus or minus sign here, but if we're talking about the solution that goes through this curve, it's either plus or minus, not both of them. So it'd be wrong to put a plus or minus here. So which one would it be? Well, if I plug 0 into this, I get 0, 0, square root of 4. But the square root of 4 is 2, so it's the minus one is the one that goes through this. And that's it.